Hello students, how are you? In today's lecture, we are going to discuss about sp hybridization. This is the third form of hybridization, and the lectures about sp2 and sp3 are also present on our YouTube channel, or you can also access those lectures from the description given below. So let us start our lecture. The process of basically mixing one s orbital and one p orbital in an atom to form two sp hybrid orbitals of equivalent energy is called sp hybridization. Basically, the name itself is indicating that sp, there are two orbitals involved. One is s and second is p orbital. And we know can see in this picture, this is the s orbital because it is spherical in nature, and this is the lobe type structure of p orbital. So they combine to form sp hybrid orbitals. So this process is called basically sp hybridization, and sp hybridization gives a linear type of molecule, which we will be discussing in detail. Let us take an example of beryllium dichloride. It is a linear molecule, BeCl2. Two chlorine atoms are attached with the beryllium atom. Basically, sp hybridization also explains the geometry of linear molecules such as beryllium dichloride. And electronic configuration of beryllium gives us an idea. For example, this is the ground state electronic configuration of beryllium atom, and this is the excited state. We can see that two electrons in the s orbital. One of the electron is jumped into the p orbital in this case, which we call it to be the excited state electronic configuration of beryllium atom. And now these two half-filled orbitals basically combine to give these two sp hybridized orbitals. And conditions are satisfied as one s orbital and one p orbital is participating in this process. Now, the sp hybridization is formed when two sp hybrid orbitals of beryllium atom overlap with the half-filled p orbitals of chlorine atom, because we are discussing BeCl2. And according to the structure, we have beryllium atom in center and two chlorine atoms attached with it. So, two sp hybridized orbital again, they combine or overlap with the half-filled p orbitals of the chlorine atom, as we know that chlorine belongs to p block elements, and we know the elements of p block, the last valence electron goes into the p orbital. Okay, so definitely the valence electrons are in half-filled atomic orbital that is going to combine with the beryllium sp2 hybridized orbitals. So we can see in the structure that there is an angle of 180 degree because of that linear shape of beryllium dichloride. Beryllium atom basically lies at the center of the both chlorine atom on either side, showing linear geometry, so that the angle is 180 because there is no lone pair repulsion. There is no lone pair bond pair repulsion. Just the only repulsion in this molecule is between bond pair. Okay. So that's why, according to the Vesper theory, all the bond pairs, they just tend to stabilize the molecule by placing themselves at the maximum distance where they could get the maximum stability. So you can see this is the beryllium atom. Okay, these two are the sp hybridized orbitals, and they are combining with the p orbital of chlorine, and this is the half-filled, and same is the case with this chlorine atom, and the resultant molecule is linear in geometry. Okay, now we take another example that is much more related to the organic chemistry, as we are going to discuss the sp hybridization in ethane. Ethane are basically triple bonded carbon atoms, So in the formation of ethane, two s and one p orbital are hybridized to form two sp2 hybrid orbitals. And to understand this phenomena of sp hybridization in ethane, let us take the example of carbon atom electronic configuration at ground state, where we can see there are only two half-filled orbitals, and at the excited state of electronic configuration of carbon atom we have four valence electrons, and these are the four orbitals. So what is basically happening here? Two orbitals, and these are the two p orbitals, because we mentioned in the definition there are two p orbitals, because this one and this one are the p orbitals. These are hybridized, sp2 hybridized, and these two will resultantly combine with other atoms such as hydrogen in case of ethane. So you can see the molecular orbital diagram. Each carbon in ethylene undergoes sp-s overlap, because we can see these are the two orbitals sp2, this one and this one. These are sp2 hybridized orbitals, and you can see this is the hydrogen atom, hydrogen having one electron in s orbital, so the overlap is going to be ssp. In this case sp over sp, because this is going to be a bond between two carbon atoms, and this is the pi bond. Similarly, these two half-filled orbitals will also form a pi bond, and this one again sp. As in this case there is an hydrogen atom involved on this side of ethylene molecule. So the overall structure is going to be H carbon triple bond carbon and hydrogen, and we can see that this is a linear molecule in ethylene. Two half-filled p orbitals are parallel to each other to form two pi bond as shown in ethylene molecule. Okay. Now we can see that two half-filled orbitals are also present that are going to form two pi bond in case of ethane. And if you remember in the first lecture of hybridization, we mentioned that we can also find the type of hybridization in any molecule just by counting the number of bonds. In this case we have carbon triple bonded to carbon atom and then hydrogen. So you can see, if you want, because we are aimed to find the hybridization of carbon atom, like this one we can count there are 4 electrons and there are 2 pi electrons and 1 sigma bond. But in case of finding out the type of hybridization, we will consider this triple bond to be the one bond pair according to the Vesper theory. So there are only 2 sigma bond, there are 2 pi bond involved in formation of ethane molecule, so it will be a sp hybridized molecule, and the bond angle is definitely going to be 180 degree, as we are discussing that sp hybridization gives linear geometry. Okay, and we know that dividing 360 by 2 will get 180. Okay, so the bond angle will be 180 because this is the maximum distance where these 2 bond pairs are stable. So this is the lecture about ethane sp hybridization, and if you want to know more about other types of hybridization, let us know in the comment section. We will try to solve the problem. See you in the next lecture.